All right, in this video we're going to look at something called De Moivre's theorem, and that says that cis theta here, cis theta all to the power of n, is just cis of n times theta. My apologies. Let me just show you how that comes about. We've got here, we can write cis theta, as we saw, as e to the I theta. I'm just suppressing r at the moment. I'm not including the modulus. Don't need to for this. And that looks terrible. Just get rid of that. Okay, again. So we now got cis theta. Maybe a bit too thick. Maybe I'll use something a little bit thinner. And we can write that as e to the I theta. But if we were to have this to the power of n, then we've got this to the power of n, and that would be e to the I n theta. Okay, that's how you can say that. Now, and we could then write that as cis n theta. All right, so that's how that's coming about. Okay, and that's how we'll use it. I mean, there are further uses. We can find other uses as well for this, as you'll see later on. But that's the key relationship, how this comes about. Just use the exponential form. Cis theta is e to the I theta, then all to the power of n means e to the I n theta, which is just cis of n theta. Okay, so let's see how we can use it. So let's say we've got our complex number z is minus 1 plus I, and we want to find z to the power of 5. What's that? Z times z times z times z times z. Okay. All right, well, let's write z in cis theta form. So the modulus will be square root of 2, okay? Square root of square of negative 1 is 1, plus the square of 1 is another 1 added together is 2, square root of 2. So that's how we get the modulus of the complex number. The angle is, principal angle is, it's in the second quadrant, so we're going to have 3 pi on 4, because in the first quadrant, if that were plus 1 here and that was 1, then we'd have inverse tan of 1, which is pi on 4. But since we're in the second quadrant, the real part here is negative. We're in the second quadrant, pi minus pi on 4 is 3 pi on 4. Hope you're all happy with that one briefly. Okay. What we want to do now is find all of this to the power of 5. So z to the power of 5 will be all of this object here to the power of 5, so square root 2 to the power of 5, cis 3 pi on 4 to the power of 5, okay, but we've already seen that that's just going to be, take that power there and stick it in front of the 3 pi on 4, that'll be, okay, so square root 2 to the power of 5 is 4 root 2, this is cis 15 pi on 4, okay, 5 times 3 is 15 pi on 4. Okay, if we were to expand it out now and go back to Cartesian rectangular form, we're going to have 4 root 2 out front. Then we're going to have cos of 15 pi on 4. Ooh, what quadrant is that in? Plus I times sine 15 pi on 4. Well, 15 pi on 4, that's, I mean, if that was 16 pi, that would be 2 pi. All right? That would be 16 pi on 4, which would be 2 pi altogether, okay? So that'd be a complete revolution. So that's just pi on 4 short of a complete revolution. So we must be in the fourth quadrant, okay? So we must be here. Okay, this is 15 pi on 4. So that must be 3 pi on 4. Now, if you just have a look at the symmetry properties here, the real coordinate, the horizontal coordinate here, well, that's going to be positive. Whether in the first quadrant or the fourth quadrant, that cos component will be positive. Minus 3 pi on 4, okay? Sorry, not 3 pi on 4, minus pi on 4. My apologies, minus pi on 4. Another pi on 4, add to that, you get 2 pi on 4, my apologies. So that's minus pi on 4. Now, cos of minus pi on 4, okay, is just going to be 1 on root 2. You've then got 4 root 2 times 1 on root 2, so that's just 4, okay? But in the fourth quadrant, sine, this component here, will be a bit there, that's going to be negative because it's in the negative direction. So we're going to have minus 1 on root 2 times 4 on root 2 will give us minus 4. So we've got 4 minus 4i. All right. How about z to the power of negative 4? Z to the power of negative 4. Well, z is r cis theta. Z to the minus 4 is all of this to the minus 4. Well, that's r to the minus 4 times cis of minus 4 theta. Okay. And what we've got is square root of 2 to the power of negative 4 times cis 3 pi on 4 to the power of negative 4. Because remember we found that z was root 2 cis 3 pi on 4. Okay, so all to the power of 4. So what we're going to have is 1 on the square root of 2 to the power of 4 times cis minus 12 pi on 4. Okay, that's 1 on 4 cis minus 3 pi, because 4 goes exactly into 12, so it's negative 3 pi. Okay, so that's like going around. I'm here like this. If I go around, there's negative pi. Keep going around. 2 pi, negative 3 pi. All right, so that's all right. Now, cos of minus, well, let's just start with sine here. Sine of n pi is just 0, so that just drops out altogether. All right, and then on this axis here, cos is in the negative direction, isn't it? Ooh, yeah, negative 1. Okay, so it's negative 1 times 1 on 4, and so what we have is z to the power of minus 4 is negative 1 on 4. Okay, and yep, that's it.